Okay, if you have the yellow test, this test correction is for you. So number 1, it says the above graph shows position as a function of time for an object moving along a straight line. During which time is the object at rest? Okay. Since this is a position time graph, the slope of the line represents the velocity. So in order for a velocity to be at rest, it would have to have no velocity or no slope. So our answer to this is B, which is from 1 to 2 seconds. Okay? No slope, no velocity on a position time graph. Okay, number 2. Okay, we have an ideal elastic rubber ball is dropped from a height of 2 meters. It hits the floor and it rebounds to its original height. Which of the following position time graphs best represent the distance above the floor versus time for the bouncing ball? Okay, so they could have done this graph 2 different ways. They could have called where they let go of the ball 0, or they could have called the floor 0. Not knowing which one they did, I'm going to take a look and see, but whether they called where they let go of the ball 0, they called that 0, then this would go down below 0, right? But my line, my position line, would start at 0. Okay, so let's say that's 0 meters. The other way they might have done it is we let go of the ball right here, but they call the floor 0 meters. Okay, so if they let go of the ball up here and they called that 0 meters, then we'll never go in the positive direction. So everything would be below the timeline. Now this one's below the timeline, but they also start up above 0, so that makes no sense. This one's below the timeline, but there's no acceleration going on here, right? We need to have an acceleration. So I'm thinking that they must have dropped the ball here and called the ground 0. Okay, so if that's the case, the ball would have fallen down while speeding up, so its velocity would have got larger and larger and larger on the way down. And then on the way up, it would have got smaller and smaller and smaller, right? So on the way down, it's negative and it's getting larger. So I need an increasing negative slope followed by a decreasing positive slope. Okay, so here I have probably a couple of bounces, and this is starting from ground level, going up and losing speed. But somebody dropped it down. Okay, so that's not going to work. Here this goes down below the floor, so that's not going to work. Here we have an increasing negative slope, so that's a maybe, followed by a decreasing positive slope. That's a good answer right there. Here there's no increasing or decreasing slope, so there's no acceleration. And here, that's a constant velocity down and then a constant velocity back up. We need it to be increasing and then decreasing. Okay. Number 3. It says, given the graph of velocity versus time of a duck flying north, that's not even a complete sentence, by the way. Remember I gave y'all extra points if you found the error? Right here. I accidentally hit a period instead of a comma, and then it auto-capitalized at. So that should be one sentence. Given the graph of a velocity versus time of a duck flying north, at what point did the duck turn around? Okay, well remember, everything up here is a positive velocity. So the duck is flying north and speeding up, still flying north, speeding up again, but now slowing down, flying north, but slowing down, flying north, but slowing down. Here's 0 velocity. The duck stopped right here. So at what point did the duck turn around? The duck never turned around. Remember, on a velocity time graph, you have to cross that line to go the opposite direction. So E, none of these. Okay, number 4. The graph above is a plot of a position versus time graph for which labeled region is the velocity positive, but the acceleration is positive. I almost said negative. So the velocity is positive and the acceleration is positive. If you're going in a positive direction and you have a positive acceleration, then you must be speeding up, right? You have to have two positives to have a positive acceleration in the positive direction. So I need a positive slope because it's on a position time graph and the slope represents velocity. So I need a positive slope and I need an increasing slope because it's speeding up. So my choices are D or E. D is an increasing positive slope while E is a decreasing positive slope. So my choice for 4 is D. Okay, moving on to number 5. Okay, since 5 and 6 go together, I'm going to go ahead and stop this video and start another video so my video doesn't cut out on me.